Welcome to this lesson on sieve analysis and soil classification. We'll be analyzing soil sample data to determine grain size distribution and soil classification. Let's start by plotting our grain size distribution curve. We'll use a semi-logarithmic plot with grain size in millimeters on the x-axis and percent finer on the y-axis. The data points from our sieve analysis are plotted here, and we'll connect them to form our grain size distribution curve. From this curve, we can determine our key diameter values. D10, the diameter at which 10% of particles are finer, is 0.03 millimeters. D30 is 0.3 millimeters. And D60 is 1.6 millimeters. Now, let's calculate the uniformity coefficient and coefficient of gradation. The uniformity coefficient Cu equals D60 divided by D10. This gives us 1.6 divided by 0.03, which equals 53.3. The coefficient of gradation, Cc equals D30 squared, divided by D60 times D10. This gives us 1.88. Let's classify our soil using both the AASHTO and USCS systems. In the AASHTO system, we have 35% gravel greater than 2.0 millimeters, 60% sand between 0.075 and 2.0 millimeters, and 5% fines less than 0.075 millimeters. In the USCS system, we have 25% gravel greater than 4.75 millimeters, 70% sand between 0.075 and 4.75 millimeters, and 5% fines less than 0.075 millimeters. Based on these results and the coefficients we calculated, this soil would be classified as a well-graded sand with gravel. The high Cu value of 53.3 indicates a wide range of particle sizes, and the Cc value of 1.88 falls within the well-graded range of 1 to 3.